yesterday, read if I can borrow this for 1 second. Yesterday, you should have picked up this double sheet. Okay, so there is some extra angular, rotational, linear, speed type problems up front, and then there is a section 4.1 review sheet in the back. On top of that, you should also have gotten at some point in time a 4.1b speed chart problem sheet and a 4.1a two-sided, on the back-side of Billy the Goat problem. Those three, okay, so those three yellow, and we're on yellow this unit. Side note, everything that we want to collect we put on the same color. This particular section's color is yellow. Those three yellow worksheets are due on Tuesday, along with, if you haven't done so already, along with your formative corrections. People turned in their formative corrections already. So we have that. Okay. Your test will be on Tuesday, and that's all that I can say about it right now, because I'm still in the process of writing. So, okay, but it'll be a good one, I promise. So here is our warm-up today. Through how many radians will the hour hand on a clock rotate in 48 hours? Hour hand on a clock rotating in 48 hours.
We're starting at
48 hours. You can start wherever you want.
okay.
Yep. What do we got? Or are we still thinking? Okay, stop yelling at me. So we're talking the hour hand on a clock, right? So that's that one right there. How many times does it go around in 48 hours? 4 times, right? Okay, so it makes 4 complete revolutions in 48 hours. No matter where you start, 48 hours later it's going to be back in the same spot. It makes 1 revolution every 12 hours. Okay? So it makes 1 revolution every 12 hours. We want to know how much it went in 48 hours, right? So then that became our 4 revolutions, okay? And then each revolution is 2 pi radians. So that would be 4 times 2 pi, which would be 8 pi radians. Yes? The kicker was that the clock goes around twice as long. Good thinking type of problem. Ooh, here's another good thinking type of problem. The figure shows the chain drive of a bicycle. Love it. How far in feet will the bicycle move if the pedals are rotated 2 full rotations? Assume that the radius of the bicycle wheel is 18.2 inches. Ooh, good one. How far? In feet. Really. What do you have? What do you have to start? What do we have to start? Nope. Nope.
Does radius move one more time?
Nope. Nope. What do we have to start? 2 full rotations. That's the only thing we have to start, is we have 2 full rotations. What's rotating at 2 full rotations? The petals. So we're over here, and we go around twice. So we're at 2 revolutions. That's our start. That's the only thing we have to start. We rotated the petals around twice. Okay? Now, from there, we can get to the tire. We have to get to the tire. The tire is way over here. Okay? We're at the purple dot. Okay? So, what do we need?
First, petals. Radius.
To get to the chain. Okay, so we got to get to the chain. All right? So if I'm going to get to the chain, I would say that 1 revolution is what? I could barely hear you. 2 pi radians. Then on top or on bottom? Okay. Now I'm on the chain. Right? So I figured out how far the chain has moved. Correct? Because it's not a speed, because we only ever have 1 unit. Okay? So now what?
Small.
Now we got to get to the angle that the small gear goes, right? Okay? How am I going to do that? Over what? Now I'm on the little sprocket. Do we need to get to revolutions of small sprocket? We need distance, right? So what can I multiply by to get me distance? Of the wheel. Yep. Because the wheel and the small sprocket are on the same center axle, right? Okay. So that means that they're going to be traveling at the same angular, or they're going to travel the same amount of angles, right? Which I have right now. So all I would have to do then is multiplied by 1 radian is 18.2 inches, and now I'm the distance of the bike tire, right? Which is how far the bike would move. Okay, well, let's get there first. You know what I mean? Because inches, it didn't assume. Oh, it did say how far in feet. I missed that part. Yes. So we need 12 inches. Well, 1 foot over 12 inches, right? Yes? So on top, I've got 2 times 2 pi times 4.85 times 18.2. On the bottom, I have 1.54 times 12. I get just over 60 feet. Yes? Yep. Could be a lot of offshoots coming off of this too. What is the angular, if we said over, if you pedal the pedals at a rate of 2 revolutions per 10 seconds, let's say, or something like that. You know what I mean? We can ask, how fast are you going? How far have you gone? In a certain amount of time frame. A lot of offshoots that come off of problems like this. What's the linear speed of the bike chain? What's the angular speed of the outside of the tire? What's the rotational speed of the little sprocket? Okay? Like 10 different questions can all come out of the same problem. Okay? Those were the 2 examples that I would like to do today. I intentionally wanted to give you time today. Tomorrow will be set up very much the same also, where warm-up problem, 1 example, work time. Okay? So instead of giving you just all day work time tomorrow, we split it up into work time 2 days in a row.